All right, we're going to do one more interval of convergence question here. Anytime we see the interval of convergence, we are going to use the ratio test. So I'm going to write L equals limit as n goes to infinity, absolute value. Always going to write a sub n plus 1 over a sub n, because that'll oftentimes get me some credit. From there, I'm going to fill the things in. Limit as n goes to infinity, absolute value. All right, I'm just going to change all the n's to n plus 1s. So I'm going to get n plus 1 squared times x to the n plus 1 over n plus 1 factorial. And then we know we're dividing, so I'm going to copy dot flip. So I'm just going to multiply by the reciprocal of this piece right here. That's going to give me n factorial over, n squared times x to the n. And then I'm going to reorder everything. Get limit as n goes to infinity, absolute value. We'll do the n plus 1 squared over n squared. And then times x to the n plus 1 over x to the n times n factorial over n plus 1 factorial. All right, so let's look at what cancels here. So this limit is equal to 1 because they're polynomials of the same degree, n squared, both with a coefficient of 1. So we just divide the 1s and it gives us that limit's 1. Next one, all of those will cancel with all of those and leave me with just an x in the top. And then we've talked about this before, but if I had 3 factorial over 4 factorial, that'd be 3 times 2 times 1 over 4 times 3 times 2 times 1. And they would cancel like that. And what I want you to see is we're left with that 4 in the bottom. 4 is 1 more than the 3, just like n plus 1 is 1 more than the n. So the way these cancel is that cancels, and it just gets rid of the factorial and just leaves the n plus 1. So this is the limit as n goes to infinity. I get 1 times x times 1 over n plus 1, which is the same as the limit as n goes to infinity of just an x over an n plus 1. Now, what happens? Well, x is, you just have to think of x as a number. Any number, right? Any number. Let it be a number. Think of a number in your head. Make it as big as you want. Big numbers. But look, we're letting the bottom go to infinity plus 1. So even if you had a really, really big number for x, the bottom's going to be bigger. It's going to go to a large number in the bottom, which makes this fraction go to 0. And what does that mean? That means that it doesn't matter the x value. This thing will always converge. So what do we say? There's quite a few ways to say this. We could say this converges for all real numbers. That's not a good. All real numbers x. You could write all real numbers of x, so all real values of x, or you could write negative infinity less than x less than infinity. That just says all values of x between negative infinity and infinity. Make it as big as you want, 2 bajillion, right? We're still going to let this limit go to 0. So any of these could kind of show up in a multiple choice. Any of the 3 of them would be good as standalone answers on FRQ. Yeah, so hopefully that helps you with this, and that'll play a role in some of the ones that we do in a little bit.